So let me just proceed to an example. Here the required mix design is C50 OPC with nominal maximum size of aggregate 19 mm, slump value 175 plus or minus 25, specified cylinder strength C50 or 50 MPa with an equivalent cube strength of 60 MPa. And if you have standard deviation, you can always write it here and it will calculate for us automatically. So let us proceed with empty or without standard deviation, and we are required to provide or to produce 60 MPa strength at 28 days. So that is 10 MPa margin from the 50 MPa. Next, our water cement ratio maximum as required by the specification in this example is 0.35 with a minimum cement content of 400. And so if we follow this 0.35, you will notice that we will not achieve the required average strength because this chart suggests us that it will give us only 51 MPa. But however, if you press this button, this automation option, so now it suggests 0.31 water cement ratio will provide us 60 MPa. So that is a very quick solution. So that is the main feature and benefit of this new template that I'm sharing to you. And by the way, you can always increase your margin. In this example, let's say I use instead of 0.31, I will use 0.3. So that provides me another 4 MPa margin from 60 to 64. And the reason behind this is because I know for a fact that I cannot control whatever is going on at site. The proper sampling, curing, demolding, transporting the sample, we don't have control over that situation. So the only way to reduce or avoid the low strength and failure of strength is simply to increase your strength margin. And that's why I realized this before, and I start creating this tool which is very effective to handle that situation, so that I can decide immediately and precisely whatever margin that I need. So I hope you get my point, how this template will help you in your creation of mixed design. Anyway, moving on forward, so let's just simply go back to our 0.31 water cement ratio. I just show you the other side of how to use this very flexible template. So anyway, again, moving into our example, let's say 0.31 is the water cement ratio, and we are expecting 60 MPa. Now moving on to the water content, which is 138 as per ACI, and of course, as I repeatedly informed from my video, I have to increase the water because of the voids of the fine aggregates that I'm using in this template. So the formula for water, of course, is simply 400 cement content in this example multiplied by 0.31. And so you notice that I have 125.5 kg of water, which is lower than the lower limit. So to cover that deficiency in water, let me just increase gradually the cement content. So let's say 465 kg of OPC. So next will be the volume of dry rodded coarse aggregate. Reference to ACI table, it suggests 0.72 the volume of dry rodded coarse aggregate. But I will use, in this example, I will use 0.65 since I need a very pumpable mix at 175 plus or minus 25. And let me just show you what I mean by that. So if you look into this table or into this combined grading, I am within the limits. So in the tarantula, and the pumpability grading envelope. This red line is our target, and reference to ACI 304.2R, we should be above this target line. So our combined grading has to be above this target line. And that is why I predetermined that the volume of dry rotted coarse aggregate must be 0.65. So you can go high and low depending on the workability that you desired. So in this example, it has to be the lower limit. So your mixture will be finer, and therefore it will tend to move or flow the mixture of the concrete itself.